Hello everyone, got a servo motor out of a heater box, and of course how does this servo motor work? We're going to look at this unit here then and figure out how this guy decides to stop the blend door in lots of positions and whatnot with an electric motor. Of course we know electric motor turns over and over and over and over but has no stopping point. So let's take a look at a wiring diagram of this first, and then we could actually go in and diagnose off of that. Of course this diagram's for the motor itself then, and if I work my way on down here, we can see that in this box that's on the outside here then we have an electric motor, a solid state device, and then we have a typical potentiometer, a lot like a throttle, exact same thing as a throttle position switch that would be in our car. So for identification we need to go through and figure out what voltages are going to be applied and so on like that. If we look at this bottom line out of this unit there then, and this is pin number 7, this is going to be a ground, and that's for the entire system to use, that the solid state device and the 3 TPS and so on there. If I go up to the top side of this, we can see the far right wire comes from fuse number 13, which is a 15 amp, so this is hot all the time, and it is 12 volts applied to that one. So if I was to back probe at that terminal, and that is terminal number 5, as you can see, terminal number 5 should be hot all the time if the circuit and the fuse and everything is good at that point. The dotted box, the shaded box that you see right here, is the heater and AC control. So this is the head that's mounted in the dashboard that you physically touch, and this heater control can come down and command this drive motor off or on that. So with that we're going to have a signal in out of this guy to then command him on over. We're going, and that's pin number 6. Over here on pin number 9 we actually have 5 volt reference, and this is going to be a signal back to the control head to tell the position that this motor is at. Notice the wiper that slides up and down on this wire, that this wire with pin number 10 has 5 volts applied to it all the time here, and then the trailing end of this wire, this coil, goes to ground on there then. So with that then I have 5 volts applied, I have a ground to this wire, and if I go in and if I intersect at different points along this wire, energy that's been given up as heat in various positions will then alter the return signal that I have to this device back in the control head there, giving me a voltage reference of anywhere from 0 to 5. And normally we could take that scale, we could chart it out, we could make this box, I could say 0 volts here, I could say 5 volts here, and then this unit will have a linear line going from 0 to 5 volts, usually never being allowed to be less than 5 volt or less than a half a volt, or never more than 4.5 volts for diagnostic code purposes on that. So again, we have 5 volts in, a return signal that will vary from 0 to 5. We're going to have a command for our motor, and this is going to be of a negative voltage here. We're going to have 12 volts in, and we're going to have a ground. So if I went right to the device itself then, we could physically take and wire this unit up, which we've done right here. Now I've just used a set board that gave me a 12 volt and a 5 volt supply, so that's just my voltage supply itself then on there. On it, because of the pins that's in this that we identified, I don't have room for all of my wires to get into this, so I did take and I used these 3 wires on pins 10, 9, and 7, which is the signal, return signal, which is the potentiometer to tell the position of my electric motor. Then I just reached right over and actually grabbed my electric motor right at the base of it instead of going to the individual terminals. Of course this electric motor has a worm gear on the end of it that goes through 1, 2, 3, 4, 5, 6 gears there to get the power up to the drive that would change the position of the blend door. And with that, it slows it down, which one, gives it more torque, and two, gives us the ability to stop that blend door in multiple positions. And then you'll note this blue gear that's over here, and the diameter of that versus the gears that's up in this area. This guy here actually has the potentiometer mounted on the bottom of it. He'll never make a full swing the whole way around, but as these guys stop in different positions, this will note the 0 to 5 volts out of that unit. So what I'm going to do is wire up the motor at this time, and we can physically watch the voltmeter itself then along with this. Let's see if we can get this to come in here then. And if I take and wire up my motor, and notice the reference voltage of 2.213, that is the voltage that's on the potentiometer. So the control head of the car, the computer, knows the position based on that return signal. Now if I was to power up my electric motor and I turn the electric motor, you can see your reference voltage moving as we increase the position, as we turn the timer unit right there. And of course we can go up till we get a total of 5 volts out of this unit. 4.5 is usually the limit on this, and of course there then at that point you can see where we stopped there then. Okay. We can see then that when I release this, the gear train's going back to where it's found a medium, and it will park with the door halfway open. And again, that's a default mechanism that's built into that. As that's going down, we'll watch the worm gear. We can see very slowly on the position sensor that moved, everything stopped, and this unit stops at 2.2 volts on that. Now if I was to reverse the voltage to my electric motor, which it does in all reality, I can wind it the other way, and by winding it the other way, that then takes the voltage the opposite way, again taking me down to about 0.5 volt on this unit, and that would be its limit on that. And then of course whenever I release it, release my voltage, this unit will then find happy center, leaving the blend door halfway open for a default mechanism. So we have 2 wires for the electric motor, that's simple there, but then we have the 3 wires for the position of our system, and that works through this potentiometer, basically a 3-wire throttle position sensor, if you will, on that. And of course it stopped at that position, leaving me at a position that is represented by 2.2 volts that the control head can see on there.